Hello, my name's Justin Hartree and I'm here at the Oxfam Supply Centre. This video is the first of a three-part series taking you right through the process of how to build an Oxfam Steel Water Tank. In this one, I'll be talking about how to prepare the ground to give the tank a good base to sit on, and then with the team, we'll be showing how to assemble the walls. The other videos, they look at the installation of the liner and all the fittings, and the last one looks at the assembly of the low-profile steel roof. So when you come to set up your tank, you're going to need to prepare the ground. This takes some planning, it's going to take a bit of time, it's going to need some manpower and some material resources. It will be tempting to do this hurriedly, to get the tank up and into operation. But as with a building or any other permanent structure, the foundations are going to be key to the longevity. In this case, it really is all about the base. So when you're setting up the tank, there are three things that you really want to avoid. Settling or subsidence, puncturing of the liner, and having water, surface water, able to pond or gather around the tank, especially if you've got an installation with numbers of tanks like a treatment works. So thinking about subsidence or settling, you're going to be supporting a considerable weight here, and that's going to be spread evenly across the whole of the base area. What you want to avoid is localized settling or subsidence, which will put stress on either the walls or on the liner itself. And this is done by carefully preparing your foundation. And the foundation is going to be slightly larger than the diameter of the tank. So where possible, build a concrete pad. And you can do this following the manufacturer's instructions. And do this carefully to make sure you've got the correct thickness of layers for your hardcore, your cement, and for your sand layer. Now, the quality of your concrete pad is going to depend on the materials you've got available and the workmanship of your team. But you need to do this properly and follow the instructions. If you're not familiar with making a concrete pad, find someone who is and get them to lead that part of the installation. If you're not able to prepare a concrete pad, you're going to be working on open ground with your locally available materials. In this case, you're going to have to remove the vegetation and any roots, dig out some topsoil, and then start to prepare a similar pad using murram or laterite. You're going to build this up in layers, compacting it at about 10 centimetre intervals. If possible, use a vibrating whacker plate to compact each layer of material. If this isn't available, make some hand tamper tools. But you have to tamp this down very carefully. Build it up to the right height and then finish it with a layer of sieved sand about 5 centimetres deep. The second thing to avoid is any chance of puncturing the liner. Make sure there are no sharp objects, stones or sticks, thorns or anything that can present a sharp edge inside on the foundation. Watch out for tree roots as well, because these will continue to grow. Also watch out for insect nests, because termites or ants could possibly eat through the bottom of the liner. There is a geotextile mat provided to put down between the liner and the ground. But this is in addition to good ground preparation. It's not a substitute. Finally, you want to avoid ponding or surface water. You may be putting up a solitary water storage tank, or you may be putting up a number of tanks in a treatment or a storage facility. You do not want to have surface water either from rain or from spillage ponding and gathering around the bottom of the tanks. So you need to think about surface water drainage, your tank overflow pipes, and also your tank washouts. Can you put together channels or build channels with enough fall to take water away from the site? And if you're setting up a treatment works, how are you going to drain away your sediment and your flock and the slurry that produces? You need some way of taking that off the site as well. A tank plinth kit can be used to raise the tank and create head for distribution. and it can be used to create a height difference between tanks on a site to move water between the different tanks. You can use sandbags around the bottom of the tank to prevent rainwater from the roof from scouring away at the base that you've made, and to prevent flood water from touching the tank walls. Now you're ready to start your tank assembly. If you're on a concrete base, mark out the circle in chalk at 6.44 meters diameter. If you're on your made base of Murram and sand, do the same, but instead of a chalk circle, dig a small trench, 10 centimeters wide, 5 centimeters deep. Make sure it's the same depth all the way around the circumference. So that's the preparation of the foundation for your tank. It's so important to take your time and get this right. As you build your tank, you want it to be there for years. So it really is all about the base. Great, so we've prepared the ground. Now we're going to start putting up one of these. Now each set of steels comes with 4 panels that have got a hole in. And you've got to decide whereabouts you're going to have your inlets and your outlets. You get 2 blanking plates in the kit, so you can cover the holes you're not going to use. And with your liner, you're going to get 4 flange kits and 3 valves. Now, when you're doing a distribution from here of treated water into a main delivering to distribution points, you're going to always use a low-level outlet. You want the maximum pressure on the outlet, and you also want to maximize the capacity you use, so you want the outlet at the bottom. Your inlet can be wherever you want. You generally use a low-level inlet if you're pumping water in and maybe you're pumping it with chlorine and you don't want it splashing and degassing and losing chlorine. Alternative, you might want to use a high-level inlet. You might want to have a float valve on it. That's going to be at the top. So you'll make that decision. In the example I'm putting together today, I've got a low-level inlet that's going to point over that way to distribution. I'm pumping in from a borehole with chlorinated water. I'm going to use a low-level inlet, and I'm going to have my overflow. I've mounted my overflow here. I'm going to have an elbow inside the tank and bring it up with a piece of pipe to the level I want for my overflow. If you're setting up a treatment works, you've got to do a little bit more thinking about it. If you're doing flocculation, you're going to use this sheet here with a hole in the center. You're going to want that as your outlet. You'll have that down at the bottom here, so that when you're doing your flocculation, all the sediment and any chemicals will go beyond that. You'll take clear water out from this height. Then you'll need a low level to wash out all that dirt and sediment. You've also got to be thinking about where you're positioning your tanks, because you're going to link them together to maintain the level in each, and you're going to want to feed from the flocculation tanks slightly higher down into the disinfection tanks, which you'll have below. So you just got to be a bit more careful about your outlets to keep your pipe runs short and tidy. So we've talked about the preparation for the build. Now let's just talk about the team. You're going to need 3 or 4 people to do this, maybe 5 people with the taller tanks. More than that, and it gets difficult to manage, and you're more likely to make errors, and you're more likely that someone's going to get hurt. So keep the team small, make sure everyone knows what they're doing, they're briefed, perhaps they've watched this video, and make sure you've got a supervisor. We're going to insist that you use gloves when you're handling the steels. You may not want to in the hot weather, but these are the sharp items, and we know that injuries can be caused. So use the gloves that are given in the liner kits. So now we're ready to start to install the lower ring of the tank wall. A top tip here is to put your liner in the middle before you start to bolt the steels together. That way you don't have to lift it over. Now, I've positioned my inlets and outlets here. I've got my outlet at low level pointing that way towards distribution. And in this situation, in my example, I'm going to be pumping in from a borehole, and I'm going to be using a chlorination dosing on the way. So I've got chlorinated water coming in. I'm going to use a low-level inlet here. As you go around bolting the sheets together, it's vital that you always have the overlap going in the same direction. If you get this wrong, it makes the second and subsequent rings harder to fit. It also reduces the structural strength of the tank. Once you're happy that everything is in the right place, bolt them together loosely, leaving off the top bolt. Make sure the nuts and washers are on the outside. Next, you need to check that the ring is properly round and level. Now, the holes in the steel sheets are larger than the bolts, so as you assemble it, there is some play. And as you tighten it up, the play will be gone. First thing you have to do is check that the line around the top of the steels is a continuous straight line. And you need to do this using a straight edge or a level. Then you need to make sure that the overlap seam is actually vertical. Again, check this with either a plumb line or your level. Then check that the rim is perfectly horizontal using a line level. If you don't have a line level, then you can use some clear tubing or hose pipe with water in. We're doing this on a concrete base, so we know that everything is level, but of course that won't be the case if you're building on Murram and a sand base. If things are not quite right, then make small adjustments by filling in or excavating parts of your trench until everything is lining up and you're sure it's round and horizontal. Check for roundness either with a tape measure or simply by stretching a piece of string from one seam to the midpoint of the opposite panel. Then turn the string around 90 degrees and check that the measurement is the same. So you're happy you've got the whole thing round, you've got it level, you've got the seams vertical. You can go around the outside now, tightening up all the bolts. You can use a speed brace and the flat blade that's provided, it's quite quick. Don't forget to leave the top hole blank though, because when you slide in the next layer, you'll need that hole. Once you've got everything in, do go around and check once more. If you get this right at this point, then everything else is easy. If you make a mistake at this point, things get difficult as you go higher with the tank. So you're happy with the first layer, you can get ready to install the second ring. I've laid out the steels around the tank with the positions with the outlet that we want them. I'm going to use this one here to be my overflow. I've put the mid-level plate here, the mid-level hole, and I'll show you how to make an overflow and cut it to the right height. Lift each panel and slide it into position so that the midpoint of the steel is resting between the overlapping steels of the ring below. Use the podger to locate the holes and then add the nuts and bolts. Continue adding the steel panels, going round the tank in one direction, adding the nuts and bolts and fastening as you go. Always make sure that you continue to use the same overlapping pattern. This is important for the strength and integrity of the tank. Don't put any bolts in the top layer. So this is the T45 tank. If you're building the 70 or the T95, you're going to be doing 1 or 2 rings higher. Now the process is the same, you just go slowly and methodically, follow that same overlapping pattern. However, you will be working at height, and safety becomes paramount then. You can get ladders and you can get a scaffold tower from the supply centre, or use whatever you can in the field, but be careful working at height, be careful moving these sharp panels when you start working up higher. And then when you're finishing the base, you want to prepare a bevel or a small ramp here with sand or a mixture of sand and cement dry, just pulled up sort of 8 centimetres, maybe 10. And that's really to stop the liner from forcing its way into the corner. If there's any settling on the base, the last thing you want is for the liner to start trying to creep out underneath the steel. So you've got your base flat, you've got your little bit of bevel around the edge, you're all level, you're happy with your steels. Last thing to do is just check your base and make sure you've got anything sharp or any nuts or bolts that have fallen in, get them removed, get anything out that could be in danger of puncturing the liner, and then get your people out of the tank. Okay, so there you have it. Everything you need to know to prepare a good base and erect the steel walls. Now remember that doing this part is fundamental to the strength, the integrity and the longevity of your tank. We want these tanks to last 10 to 20 years with minimal maintenance, so it's worth taking your time and getting these bits absolutely right. In the following videos, I'll be showing you how to install the liner and the fittings, and then we'll be showing you how to assemble the low-profile steel roof. Thanks for watching. If you've got any questions or feedback, please get in touch with us through our website.